Welcome everyone to episode 23 of Games with Go. Today we're going to continue the RPG project and hopefully start rendering our dungeon with our with our tiles. So one of our viewers noticed that last episode we didn't actually set our map tiles in load level from tile. We allocated space for it. We created all the all the slices, but didn't actually set them. So we're going to need to do that before we can render anything. And while we're at it, let's make a blank tile, which will just represent a spot on the map that has nothing there. It'll just be like rendered as blackness. And we'll treat any white space character in our maps as that. So in this case, there might not be any if there's no extra white space, but well, yeah, there would be one here and one there. And we should treat any white space like that. So space, tabs, new lines, and so on as just blanks. So let's iterate through. So for Y, range over level.map. Let's call this column. Easier to think about. And is that right? That's going to be row for each row. And for each no. Let's just do it like this. We'll do for y is equal to 0. Y is less than length of and for x. So let's see, got level lines. So we're going to get one line of text that we've read in for each row of our map. And then we're going to iterate over each character. So for each character, let's see, I colon character in range of line. Can we do that? Yes. Okay. We might not need I. I think we just need C. So we can do a switch on the character. And then we can check each case. We can say, actually, let's try this. Let's see if C is white space. Or some other ones. Then we'll set this equal to blank. Otherwise, let's see if we can cast. Let's see what's wrong here. Invalid character, literal, more than one character. Okay, wrong slash. Okay, so if we have a white space, we're going to set the level blank. Otherwise, we'll cast the character to a tile, and that should be a runtime error if that cast can't happen. Why don't we test that now? So let's do that. Go to main.go. Okay, we're still just rendering our sprite sheet. No runtime errors. But let's let's put a character in here that it doesn't know about. Let's see what happens. So no error on that either. Let's print that out and see what it's interpreting it as. Let's do it like this. Let's make it simple. So it's just treating it like it's valid. Okay, that's good to know. So there's no runtime check when you have a type alias, only compile time. So it's getting set to something that it supposedly can't represent. Which makes sense, because ultimately the tile is just the rune. These are just constants. Okay, so we'll have to do a switch. So we'll do switch on C. And then case white space. Make it blank. The reason we want to do this is if someone puts in invalid characters in the map, we want to know about it and report the error and crash. We don't want to just render junk. I'm gonna make this a little less verbose. What's pound wall? Stone wall? And dirt floor. Then we'll have a default where we panic and say invalid character in map. And then we could print that character out, I think. All right, we'll figure that out later. Then at the end of our switch, we'll say level.map equals T. Pull out format, so we're not using it right now. Okay, that runs with no error. Now let's put some bad data in. And now we get a panic. Okay, good. Next step is rendering it. So last we left off, we were setting up an index where we take each type of tile and map it to an XY coordinate in our texture. Let me bring up our texture here. Right, so we're mapping it to one of these tiles. And we were loading up that index in here. Yeah, and load texture index. So now that we have the texture index, we need to build SDL rectangles to represent each tile we're going to load. So let's see. Got our texture index. Are we setting that anywhere yet? Okay, so far we just have the X and Y values. So we need to compute the SDL rectangles. So that should be pretty simple. Rect is equal to SDL.rect. And this just takes an X, Y, width, and height. And our X is going to be, I think, just X times 32. And the Y is going to be Y times 32. And the width and height are 32. Oh, this should be struct, constructor syntax. And then we just have to cast all these to int 32s. Then we're going to put that into our texture atlas. So we'll say texture index. So texture index of tile. Okay, so that should let us then get the rectangle we need for each tile room we're given quickly. Welcome, Sam ZLS. Yes, we have a stream using Golang. All right. So now in our draw, we're not just going to be drawing the whole texture atlas anymore. Let's get rid of that. And let's get rid of the we did something. We know that now. So now we need to iterate over all the tiles in the level. So level.map. I guess we can just do it like this. So y is equal to range level.map. And then our row equals level dot. Do like this. Is it going to be happy with this? Declared not used, declared not used. That's fine. Okay, so we need, for each tile, we need the rectangle to pull it from. So that should equal texture index of tile. And then we're going to need to draw it from our texture atlas. And the source should be that rectangle. And the destination should be X. Let's see. Let's call this source rect, so it's clear. And destination rect. And that will be X times 32, Y times 32, and 32 by 32. And gotta cast again. And it wants pointers. That's fine. All right, see what happens. Assignment to entry in nil map, line 42. Sounds like we need to actually make our map. So let's see what the syntax is for that. We turn to documentation. Okay, so just make. So we'll do that at the top here. Texture index equals make map game.tile STL. Okay, so now we've allocated space for our map. Let's see if we can do it now. Oh my gosh, we're doing something. It's not entirely correct though. So let's have this, I'm gonna have this just do an infinite loop instead of pausing for 5 seconds. So it looks like it's pulling, let's print out the tile runes we're getting. And see if they're really all the same. $35, $35. They are all the same. So we have a mistake somewhere. Probably in here. So why would they all be stone walls? One, two, three, four, five. 1, 2, 3, 4, 5. Okay, so it's the right shape. All right. Does anyone see the mistake? It seems like we're always maybe going to see if the line's getting loaded in properly. Okay, yeah, the lines are all there. Let's see what we're getting for our characters. Getting different characters there. Oh. Yeah, we're doing this twice. We're iterating over the X and then again. This should just be like that. There's your problem. All right. We're doing it. It looks like we have the wrong index for our door. But other than that, we're close. So let's fix the door. Let's see, where is the door? This is the door we wanted. So the X is 1169. Divide by 32. So that should be 36. What did we say in our index? 17? There we go. All right. Now we're doing it. Now we're drawing a dungeon. And we should be able to draw anything we want now with these characters. So let's make it a little bigger. Make a long hallway. Then we'll do a really big room. This will just give us some space to test with. Invalid character. What did we give it? Oh. All right. Too big to fit on the screen, and that's fine because we're going to start scrolling things around eventually. Okay, so next up is we noticed last time that these tiles, a lot of them have different variations. Like the stone wall has all these different variations that can kind of go together. And we wanted to be able to kind of randomly apply those variations so that the dungeon doesn't look so regular. So the way I wanted to do that is to add an extra parameter on here for how many of the adjacent tiles should be included. So here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks like 12 stone tiles in a row you can use. And then for the dirt, 2, 3, 4, 5, 6, 7. And then for the door, I think there's just one that we want to use. For now, anyway. Like these look like special doors, so we might want to save them for later. So it'll just be one door type. Okay, so now to load that up, what we need to do is let's see, variation count. So split XY is really split XY count. So we'll change its name. Yes, our map editor is amazing. In fact, you can use any text editor in the whole world to edit maps. So it's cross-platform. Okay. Strings dot string space. Okay. So now what we need to do is build up a list or a slice of rectangles that we can use. And we need to pick them randomly. Maybe not random, maybe we'll go in order. That way it's always reproducible. But in order wouldn't look as nice. No, we can pick them randomly. So Rex is going to be an array of STL rect. And we'll append the X and Y. And then we'll say X so one trick here is we can't just add to X because sometimes these wrap around, right? Like maybe this orange brick goes to the next line. So we need to see how many total, what's the total width here? So 2036. So 63. And then let's just do it like this. X equals X plus 1. If X greater than 62, because it starts at 0, then X equals 0, Y plus plus. That's simpler logic to deal with. Okay, I think that'll work. Then we need to change our map to take an array of recs. Lowercase append. Okay, so now we're putting an array of rectangles for each tile rune. Then when we draw, we'll need to pick randomly. And we'll need to have it be random but reproducible. We don't want to like map every frame to like change. So probably what we want to do is set a seed. Have we imported math.random yet? There we go. So we'll give it some seed. So every time it draws, it's going to start with the same set of random numbers we're going to get. So source rex is now what we're going to get. And then we'll say source rect is equal to rex of math.rand, no, just rand int in length of source rex. So we get a random number between 0 and the length of source rex, which will pick out a random rectangle from the source, a set of possible source rectangles. That might be it, as long as there's no bugs. False. So this is a common mistake you can make in Go, is if you have a variable named here, then inside a different scope, inside this for loop is a different scope, you can create a new variable of the same name, right, with that shortcut syntax. And then that ends up being, they both exist at the same time, but you can't see this one from inside here. And you can get really confused when you get different data outside the scope, because outside this scope, this one goes away and you're back to this one. So look out for that. Invalid argument to int in, what did we get? So let's print it out and see. Oh. That happened down here. We had a source rect of length 0. Let's figure out why. Also, we should be checking error here. So I'm just going to print out the length of all the recs as we go along. And see why we got one that was all right. We're printing out too much stuff. Let's clean some stuff up. Let's take that out. That up. Okay, there we go. So we got rectangle lengths 12, 7, and 1. So none of them are 0. So let's see what they're like coming from the map. Okay, yeah, so we got one with 0. Oh, you know what? That's probably a blank. We didn't give anything for blank, so all we need to do is say if tile is blank, or say if tile is not equal to blank, do stuff. Otherwise, so we still got one that was 0. We've got a tile making it in. So we're getting back something from let's just see when we make the level. T is never 0. Oh, I know what's wrong. The problem is the lines are not all as long as the map is. So we have maps that are not set. What we should probably do, can we do this? All right, I did it. So what was happening is I was only iterating over the lines we were getting from the file, which are not always as long, like some are longer than others. And so we weren't filling in every single level.mapxy. And so some were set to 0, which wasn't a valid tile because blank was previously set to space. By setting blank to 0, that kind of solves the problem. Then we don't have to iterate over stuff that's not going to have any data in it anyway. So there we go. Now we have some random variation. And it should be the same each time we run it. So like right here we have a cracked wall. Here we have a clear one. It should be the same if we run it again. Yep. All right, I guess next we should start putting a character in here. And then we can start moving the character around. So let's make a character. So let's say that we're going to say we'll use the letter P for player. And we got to pick a tile. Although we've got some work to do before we pick a picture, so let's not do that yet. So one thing we need to figure out is if we had a really fancy editor, what we would do is have something like layers, where you could have a layer where you draw the map, and then a layer on top of that where you put players and monsters and chests of gold and so on. So we're not going to have that, at least for right now. So we need to figure out, if I have a player here, we need to actually figure out what's under the player. And the way I was thinking we could do that is just find the first floor tile that's adjacent to the player is what we'll set it to. So let's try to do that. Let's go to our level. So our level currently has just the map. We need to also have the player. And we need some sort of representation of the player. And for now, let's just say that we have a position. And we're going to have lots of different things that have positions and that will share some other properties possibly. So let's make a type entity, and it'll have an X and Y on the map. And the player will embed an entity in it. So the player will have an X and Y as well. So now when we load our level from a file, we need to consider the case of getting a player. Big thunder outside. And if we get a player, let's do this in 2 passes. So we'll make a map type pending. Can we do a -1? Seems okay. So the pending type will just be a placeholder. And then when we're done, we'll go over the map again. And we'll say if tile is pending, then for So what we're going to do is we're just going to look all around at all the adjacent squares. And the first one we find that's a floor tile of some kind, we're going to set it. So right now we only have dirt floor, but eventually we'll have more, so we'll need to search. So if level.map search y search x, let's do this, search tile equals and we'll switch on it. And we'll say so we also want to break out of this loop completely, out of these two loops. So we'll need a label break. Okay, so yeah, we can name a loop and then break out of that loop. So we can name this search loop. And once we find a floor to set, we can break search loop. So we're done. So let's give that a try. So we have a player in here, but we should end up with a dirt floor. Okay, that works. We still got a dirt floor. But now we want to render the player. So it's part of our level. So our UI will have it. So after we're done, let's get rid of that prep line. After we're done drawing all the tiles, we can then draw the player. So we need to pick a icon. If anyone in chat has a favorite, I don't know how you'd even point it out. Let's start with this purple wizard. He's interesting. Okay, so 691 is 21. And 1908. 59. So we'll take our renderer.copy. And for now, we'll just put him, we'll put him whatever his XY is. So we'll do, what do we do here? These need to be capital so that they're exported. The Greek pirate in chat asks, where is the tile set from? Yes, it is from Stone Soup. Yeah, Stone Soup made them public domain. It should be, here, I'll give you the link. Should be .org. There you go. Okay, but now we need to actually set the players X and Y. So we can do that here. So player okay, that's cool. He's drawing, but in the wrong place. Let's see why. I think it's in the wrong place. Yeah, that's the wrong place. So he's just going to 0, 0. Oh, we have to multiply this times 32. All right. We're now rendering our purple wizard. And because we set alpha blending on, it's transparent properly, so that's good. All right, we can pull this print line out, because that seems to be working. So next up is we need a way to get input from the UI and back to the game. So the game can then change the state of the game and send it back to the UI to draw again. Right now we're just drawing it once. So what we need to do is have some kind of input, like result struct, that the UI can return. So that might look something like this. We'll call it input, make it a struct. And let's for now just do, we're only going to do keyboard presses. And so chat asks if we're going to use SDL Mixer for the audio. Not sure yet. In an earlier project we used just the regular SDL. Has the ability to play a single sound as it is pretty easily. That's all we've done so far. So we'll see. I mean, if we want to play music and have sound effects, we'll have to use either SDL Mixer or roll our own, and it's pretty hard doing audio from scratch. So we'll see. Okay, so for now, let's just say let's just see what key was hit. So we'll get back. I'm going to make this really simple because we have 5 minutes. So this is definitely not how it's going to remain. We'll flesh this out later. And we'll rename this to draw, then get input. And it will return an input. And we'll say input we'll have a game loop here. And here we'll do something with the input to change the level and then draw it again. And this will need to become draw, then get input, and it will return a game dot input. All right, we're running out of time, so I think we're gonna stop here. But we're starting to see how we're gonna make the game work with the separate UI component. It's basically going to be a series of getting input from the UI component, changing the state of the game, and then asking the UI to draw it again. And this is kind of similar to how client-server games work. And in fact, organizing it this way would make it pretty easy to make this multiplayer later if we wanted to. Where the UI, all it does is get input and forward it to the server. In this case, the server is just our separate package, basically. And then the server makes the game happen logically behind the scenes, and then provides that new state back to the UI to be drawn. So this is how things are going to work. And next time we'll start setting up the input properly so that we can get key presses and move our guy around. And we'll see if we can also make the map scroll as we move down the screen. So that'll be next. Any questions about today's episode or previous episodes before I log off? And by the way, if you enjoy the stream, you can subscribe, which gets rid of the ads on Twitch. And also you'll get access to the source repo. At the end of every stream, I submit the code as it is and create a release so you can see the code as it was after any given episode. And if you have an Amazon Prime account, you can use that to subscribe for free. I'll hang out for a little bit in case there's any questions. All right, everybody. Looks like there's no questions, so I will see you next time, and we'll start being able to explore the dungeon. Good night.